A wonderful good morning, ladies and gentlemen. I welcome you here at the Technical Forum at the group exhibit Hydrogen, Fuel Cells and Batteries. I would also like to say good morning, good afternoon or good evening to our online guests. We are live streaming from the fair, 25 different countries here at the group exhibit, even more right now watching us from all over the world. Our today's topic is stationary and off-grid fuel cell applications. My next speaker will be discussing ultra-clean multi-megawatt fuel cell power plants with 60% electrical efficiency. Usually we have 25 to 35 efficiency. Now we have 60%, and I'm really interested how this will work. So please welcome with me on stage Senior Sales Associate of Fuel Cell Energy Solutions, Mrs. Katja Mattner. Big hands, please.
Thank you very much, and welcome here again at the Technical Forum today. My topic for today will be ultra-clean multi-megawatt fuel cell power plants with 60% electrical efficiency. As energy transition as a major topic in Europe and worldwide at the moment, and it's actually affecting all areas, starting at residential applications and commercial applications, but also going, of course, into industrial companies and utilities. The key for successful businesses are high efficient solutions, also there in all parts of the business. So fuel cells can support you there with a very high energy efficiency, while not only saving energy and saving resources, but also saving money. So here we have the European goals for the energy transition, where you can see that this again, energy efficiency is a large topic. So we want energy savings, we want less greenhouse gases, and more renewable energy. And from the other point of view, we also want to have energy security here in Europe. We want lower energy costs and a very strong European economy. And that's how stationary fuel cells can contribute to each one of these points. So as you can see, we save primary energy, we have lower emissions, and you can use them decentralized to secure your energy supply. And being a technology driver here for Europe, being a job creator. So there's a higher chance to reach the European goals with stationary fuel cells. And stationary fuel cells are of major importance also because you can use them in CHP applications. So why CHP applications and why distributed CHP? Because it's more efficient and because you don't have the losses of transmission. So as you can see in the chart here, in the centralized conventional methods, you have quite a big losses in energy transition. But if you generate your electricity and power on site, the losses are very limited. So you can save here already up to 25% primary energy just by having your own decentralized energy supply. So are these solutions reliable and commercially and affordable, available already? Yes, they are. There are more than 300 megawatt installed and in backlog at FuelCell Energy and FuelCell Energy Solutions worldwide already. We have more than 110 direct fuel cell power plants operating worldwide, and our largest fuel cell power park, you can actually see down here, has 59, so also almost 60 megawatts of installed capacity. So you see fuel cells are growing, they're getting an even more impact on the energy supply side. And with the high efficiency, of course, you drive down emissions very much. So FuelCell Energy Solutions is the partner here in Europe, producing here in Germany actually, and also having a strong background of those two companies, as it's a joint venture of Fraunhofer IKTS, who brings in patents, IP, and more than 150 experts from the fuel cell technology. And FuelCell Energy from the US, a Nasdaq-listed organization who has licenses for patents and more than 20 years of production know-how in molten carbonate fuel cells. And there are again more than 250 experts on the molten carbonate fuel cell side and more than 650 employees worldwide supporting also the European company FuelCell Energy Solutions in here. So what we are offering are fuel cell power plants that are fuel flexible, so you can use natural gas or biogas, which is available in almost all locations, at least here in Europe. But we can also use LNG, for example, if there are places that are not connected to the gas grid, for example. And what we provide is not only power with a very high efficiency. As you can see, we have 47% with our standard products, 60% with the high efficiency fuel cell I'm talking about today, and we have a very high availability. We just published a study about our Bridgeport fuel cell park, which reached in the last year also more than 59% of availability. We also have the high temperature heat available, so the exhaust air from the fuel cell, which is actually air and not exhaust gas, has a temperature of 400 degrees Celsius roughly. So you can use it for steam applications, you can use it, of course, for standard heating, or also, that's the next point, for absorption chilling. So if you drive those 400 degrees Celsius directly into a absorption chiller, you can use it for refrigeration or also for cooling your buildings. As we use methane in our process, we can also extract hydrogen within our fuel cell process, delivering hydrogen, for example, to refueling stations for cars. So as you see, our technology is very versatile. You have a lot of ways to use them, but today I want to stick more to the high efficiency solution. And just want to point out, of course, the emission behavior. So in here, we just want to point out that the DFC technology, again, is almost free of emissions. And we compared it to a German regulation, which is called TA Luft. And as you can see, the DFC fuel cell power plants are way below the measurements of the regulation. And just to visualize that as well, again, we over here have it compared to other heat and power technologies, going from engines to turbines, and compared with the fuel cell technology. So you can see there's a major impact on the emission profile here as well. So our solution is for ultra-clean baseload distributed generation because it's easy to site in populated areas. You can use it in inner city buildings, for example, as well, as there are no vibration. There's no burning process going on. So it's just a very quiet electrochemical reaction. So yeah, you can use it inside of buildings, you can use it outside of buildings, and it's very quiet and there are no vibrations. Then, of course, the high efficiency, as mentioned before, which is even higher in the total efficiency if combined in a combined heat and power usage. And because you can use natural gas or biogas, you can basically place it wherever you like because that's usually available. Our focus markets are on-site power generation for industrial customers, for example, but also electric grid support for utilities. The drivers here are again, of course, the high efficiency and the virtual lack of pollutants, again, for inner city applications or also for production facilities that are looking for a greener image and are looking for power reliability. Same for the electric grid support. It supports the grid reliability, and it can be used as a very cost-effective power generation where you need to support your grid as a utility. But now coming to a few examples, just to show you how far we are already. So on the left-hand side, you see a 1.4 megawatt installation at the Central Connecticut State University. They're using the high efficiency to drive especially savings. and for the or the heat for cooling and heating processes at the university. And ultra clean emission profile supports their sustainability goals. In the middle, you see the Bridgeport, Dominion Bridgeport FuelCell park with almost 15 megawatt, and here the power is sold to the grid. This is a mixed area where there are like houses, residential houses close by, but also industrial houses close by. So you have renewable baseload power right where you need it in the industrial surrounding, but very quiet, so the residential don't have any problems with it. And then on the right-hand side, it's again a university, but at this time the university is not the owner itself. A utility owns the plant, and again the university has a profit of the savings out of this CHP. Okay, but now coming to the high efficiency fuel cell. So this module has 3.7 megawatt in standard application and has an electrical efficiency of 60%. It's especially suitable for customers with large load requirements but limited waste heat utilization. So, for example, data centers that need especially the electricity to feed their data centers, but not that much heat, for example, to cool them. So, in our standard product, we only have those two modules. In the high efficiency fuel cell application, there's another module added, which I will explain later on. So the advantages here of the high efficiency fuel cell. So this is the standard configuration I was mentioning before, 2.8 megawatt with 47% electrical efficiency. We already had a development to increase the electrical efficiency to 58% with the turbine. But we noticed that it's for us, it's better to leverage our proven DFC fuel cell technology to only use one technology to reach the 60% as it's proven worldwide and in operation worldwide and reach the higher efficiency. Also, we need less water, 20 to 30% compared to the DFC turbine, and it has a smaller footprint and lower installation costs. So we are looking at roughly 20% lower installation costs than at the DFC turbine. And what's happening? What we did is we have the DFC 3000, where the fuel is going into a heat recovery system, getting preheated before it goes into the two modules you've seen before. It goes to the anode, to the oxidizer, and back to the cathode. And the heat is recovered here, used to preheat the gas. What's new now is that fuel is coming again into the heat exchanger, getting preheated, going to the anode, but now the stream is leaded to another module, the third one you've seen before. And here there's the process with the oxidizer, and then the stream is going backwards to the cathode, through the cathodes of the first modules as well, and going back to the heat recovery unit. So here we reach 3.7 megawatt with an electrical efficiency of 60%. And what are markets for this application? So of course, as mentioned before, customers with a high demand of electricity, but also at least for a bit of high temperature heat, as we still have, of course, heat available at the end of the process. So for example, electric utilities for on-site grid support and IPPs, but also industrial customers with a higher demand for electrical efficiency. And as mentioned already, data centers, because they have a high need for electricity and a lower need for heat. And as we say, it's affordable. This is a comparison you see on the left-hand side of the levelized cost of energy, and you see unsubsidized. So in our calculation, we took all the subsidies away, and unsubsidized fuel cells are actually quite cheap. That's surprising, but that's actually the point also here in Germany. So if we compare with other technologies, fuel cells are not that expensive anymore, especially if you look into large-scale applications. There are a lot of smaller scale applications available. Also, our smallest application is 250 kilowatt. But if you look more and more into the multi-megawatt application is getting, we drive the cost down per kilowatt and also the cost per kilowatt hour as explained here. So what are the benefits and savings of the fuel cell technology? So as mentioned, it's fuel flexible, so you can use natural gas or biogas in the process, and you can already almost site it wherever you like, because it's a very silent operation and you don't have any vibrations. That's why those buildings you see here, these are our European installations with Crown Estate in London, the Ministry in Berlin, and Fenchurch 20 in London again. So you have a very reliable baseload electricity, which is continuously providing power and high temperature heat, so you can use it as a CHP application, and it has a unique low emission profile that supports your sustainability goals. And yes, there's not much service to do because there are no moving parts. So it's a very simple and effective service. So it's a very safe solution for our customers. So yeah, thank you very much for your time, and I invite you to visit our booth. One is right over here next to the forum, and the other one you can find just further down the aisle at J5033 at the Decentralized Energy, where we also show our largest fuel cell stack of the world with 400 kilowatt capacity. So, yeah.
Thank you very much also from my side, Mrs. Katja Mattner. Is there a question from the audience at this time?
If there might be questions later on, as I mentioned, please feel free to come to one of the booths. We'll be happy to answer.
I do have a question, though, I would really like to ask. So you mentioned the costs that are going lower and lower. Does your cost analysis also include the replacement cost after end of life?
Yes, our power plants are made for a lifetime of 15 to 20 years. And in our full service that we offer to every customer, there's also the stack exchange excluded. So there's no risk for the customer side. We include everything and also assure that the power plant is delivering the power, as we have a power output guarantee in our contracts as well.
Does that also include maintenance?
Yeah, all of it.
Thank you very much.
All right, thank you.
Now here at the technical forum at the group exhibit Hydrogen Fuel Cells and Batteries, we will have an hour break. So there are no talks to enjoy for an hour. We'll be back at 1 o'clock and we'll be discussing more topics about stationary and off-grid fuel cell applications. Thank you very much and have a wonderful break.